The A-40KT was one of the dead ends of war technology. It's one of the most original and mysterious Soviet weapon designs from the Second World War. The Soviet Union had a penchant for turning audacious dreams into metal and muscle, often ignoring practicality in favor of ambition. From flying fortresses and hovering tanks to nuclear trains and sea-skimming monsters, Soviet engineers pushed the boundaries of imagination and technology. This monstrous vehicle, part ship, part airplane, is on a beach by the Caspian Sea in the Republic of Dagestan. Colloquially, this one is called the Caspian Sea Monster. Some creations never left the drawing board. Others crashed spectacularly, and a few achieved fleeting operational use. So, were the USSR's strangest, largest, and most jaw-dropping military and aviation experiments. Let's delve into the Soviet Union's machines of ambition that's so crazy they were banned. T-42, the Soviet land battleship that never left the blueprint. In the early 1930s, armored warfare was going through its experimental jazz phase. Everyone was throwing strange ideas at the wall to see what might stick. And no idea was stranger or heavier than the Soviet T-42, a super-heavy land battleship that promised to crush enemy lines beneath 100 tons of steel, assuming it could ever move in the first place. Before modern tank design settled on one turret, lots of armor, the world flirted with the fantasy of multi-turreted monsters. Britain had the A1E1 Independent. Germany toyed with similar concepts. And the USSR, never one to be outdone, said, let's make one with 5 turrets. The logic was simple in theory. More turrets meant more guns, more directions of fire, more destruction. In practice, it mostly meant confusion, weight problems, and vehicles so long they needed their own zip code. But in the 1930s, this wasn't obvious yet. Back then, multi-turret tanks were seen as the future, rolling fortresses that could blast their way through enemy lines. Designed under the direction of German engineer Edward Groth, the T-42 wasn't just big, it was absurd. The plan called for a tank weighing 100 tons, twice the size of the later T-35, and several times larger than the light tanks making up most of the Red Army's fleet. Its arsenal resembled a compact armory. A 107mm cannon dominated the main turret. Side turrets bristled with 45mm guns, and machine guns sprouted wherever metal would hold them. 5 turrets, 5 crews worth of headaches. To move this beast, Groth optimistically penciled in a 2,000 horsepower engine, a thing that did not exist in the USSR or basically anywhere at the time. Had it ever been built full-size, it would have made the T-35, already nicknamed the land battleship, look like a medium tank. Now, all this sounds impressive until you remember tanks actually have to operate in the real world, not just on engineering tables. Bridges were the first hurdle. The T-42 would have flattened most in Europe. And on the rare chance one survived, engineers would likely have stopped it out of sheer terror. Its speed offered no salvation. 100 tons powered by a fantasy engine meant infantry could stroll around it, grab lunch, and still catch up. Transport was a nightmare. Forget trains, trucks, or any road that wasn't suspiciously overbuilt. By 1932, the Soviets had to face facts. The T-42 was too complicated, too expensive, too heavy, and too dependent on technology that simply didn't exist yet. Meanwhile, the more practical T-35 was already advancing through prototype stages. Still huge, still awkward, but at least buildable. But Soviet engineers didn't just think bigger. They also thought stranger. So much they imagined a tank that didn't need wheels or tracks at all. 2B1 Oka, the Soviet nuke cannon, when the United States rolled out its absurdly oversized atomic ante. The Soviet Union took one look and decided to find its own answers to that. Thus began the strange, spectacular, and very short-lived saga of the 2B1 Oka, a nuclear cannon so powerful it might as well have come with a warning label that read, "May cause self-destruction." In the 1950s, both superpowers became obsessed with the idea of portable nukes. Not missiles, those came later, but giant steel dinosaurs that could lob atomic shells across the countryside. The USSR absolutely refused to look like it was lagging behind. So its engineers got to work building something that could match America's nuclear showpiece. What they came up with was part tank, part mortar, part fever dream. The Oka's core concept was simple. What if we build an artillery gun, but made it enormous. So enormous, in fact, that its barrel was 20 meters long, longer than a city bus, and almost comically oversized on the T-10 tank chassis it rode on. The whole machine stretched to 27 meters, weighed 55 tons, and fired a 420mm shell. What if you strapped a 420mm mortar onto a tank chassis? That was the 2B-1 Oka, a machine of sheer power, shocking parades, a projectile the size of a small refrigerator that could carry a nuclear payload of 10 to 15 kilotons. That's basically Hiroshima in a bullet. Loading it required a mechanized system, lots of patience, and probably a prayer or two, because each shot took several minutes to prepare. In theory, the Oka could hit targets up to 45 kilometers away. In practice, well, the recoil alone made sure theory and reality rarely spoke. When the Oka fired, the earth shook. So did the chassis and the suspension, and probably the crews will to live. The recoil was so violent, it could reportedly shove the entire machine several meters backward, undoing all the careful positioning that artillery crews usually rely on. Even with reinforced torsion bars, shock absorbers, and a special suspension lock system, the Oka had a talent for damaging itself every time it did the one thing it was designed to do, fire. Transporting it wasn't any easier. It was too long for rail cars, too wide for many bridges, and too unwieldy to move through anything resembling normal terrain. You don't drive a 27-meter nuclear mortar through town, unless your goal is to take out the local infrastructure without firing a shot. Still, the Soviets proudly paraded a few Okas through Red Square in the late 1950s, scaring foreign observers and probably confusing everyone else. By the early 1960s, missiles like the Luna, Mars, and Scud arrived, making the Oka instantly obsolete. Why haul around a giant steel giraffe that injures itself when you can fire a compact, reliable tactical missile instead? Only 4 Okas were ever built. None saw combat. None were particularly practical. Today, the last surviving Oka sits in the Kubinka Military Museum. Less a weapon, more a monument to the Cold War's habit of turning bad ideas into big machines. And yet, even this wasn't the USSR's wildest, oversized dream. The 1K-17 Shadi, the laser tank that tried to blind the West. If the Cold War ever had a moment where reality flirted with outright science fiction, it was when the Soviet Union decided to build a tank that shot laser beams. The 1K-17 Shadi compression was the USSR's answer to a question nobody had asked. What if we made a tank whose sole purpose was to blind the enemy? And yes, it looked exactly as weird as it sounds. During the 1970s and 80s, both superpowers were obsessed with futuristic weapons. The United States explored space-based missile defense. The Soviets stared at those concepts and said, "Hold my vodka," before sketching out their own laser platform on a napkin somewhere in a military design bureau. American films were imagining X-wings and lightsabers. Soviet engineers were imagining something closer to, what if a barn was filled with laser pointers and placed on tank treads? The planner's dream was bold. Build a weapon that could blind NATO. Literally. Disable missile seekers, aircraft targeting systems, tank optics, anything that relied on a lens. With 12 powerful lasers, each that could operate separately, it could target the advancing machines of the enemy, such as helicopters, jets, and tanks. In theory, one burst of high-energy laser light, and an incoming enemy missile becomes blind, confused, and ideally useless. In practice, we'll get there. The Shadi didn't emerge overnight. The USSR had been tinkering with laser-based anti-optical weapons since the early 1970s. The earliest prototypes were gloriously crude. Basically, armored vehicles with what looked like scientific lab equipment awkwardly bolted to the roof. These early attempts proved the basic idea might work, but they also revealed the biggest challenge. Laser weapons need an absurd amount of power. The kind of power that makes your tank groan, wheeze, and consider retirement. Still, Soviet engineers persisted. And by the late 1980s, the final version arrived. The 1K-17 Shadi. To give this Frankenstein machine mobility, engineers mounted the system on the 2S-19 Master S chassis, a reliable self-propelled artillery platform built to haul heavy equipment. But what everyone remembers are the lenses. At the front of the turret were more than a dozen oversized crystal lenses arranged like a cluster of glowing alien eyes. Behind each lens was a solid-state laser amplified by crystal rods. Extremely high grade, extremely expensive, and extremely finicky. Some Soviet technicians joked that the tank had a smile full of diamonds. Turns out, that wasn't far from the truth. Unfortunately, the Shatia ran into problems no amount of Soviet enthusiasm could fix. Its laser system devoured monstrous amounts of energy, straining even dedicated generators and backup batteries, while weather, fog, rain, snow, or dust scattered its beams, making it only truly effective on a warm, dry, clear afternoon, more suited for a picnic than a battlefield. The crystal amplifiers were staggeringly expensive, threatening to bankrupt a small republic. And by the early 1990s, the USSR itself collapsed, taking the project with it. Only 1 or 2 prototypes were ever built. One was scrapped. The other sits in a military museum, missing its expensive laser lenses like a giant eyeless relic from a future that never happened. In the end, the 1K-17 Shatia was equal parts genius and folly. It was a tank that fired beams of light decades before Hollywood made it cool again. And yet it couldn't overcome the messy realities of physics, weather, and the Soviet budgets. Still, it remains one of the Cold War's strangest what-if machines. A reminder that sometimes the line between brilliant innovation and glorious failure is about as thin as a laser beam. And if you think a laser-blasting tank was wild, wait until you see what happened when Soviet engineers tried to build a 50-ton artillery cannon designed specifically to fire nuclear shells. VZCharke Molodets, the Soviet nuclear missile train that hid in plain sight. Picture a quiet Soviet railway at night, a line of boxy freight cars rattling across the steppe, indistinguishable from thousands of other trains carrying grain, coal, or machinery. Except this one wasn't hauling anything so ordinary. Inside its unremarkable steel walls sat 3 intercontinental ballistic missiles, each capable of ending cities. The VZCharke Molodets, the most terrifying game of nuclear hide-and-seek the Cold War ever produced. By the late 1970s and early 80s, the Soviets were looking nervously at American Pershing II missiles in Europe. Fast, accurate, and alarmingly close. The USSR needed a nuclear force that could survive a first strike, something the United States couldn't easily detect or destroy. Their solution? Don't bury the missiles. Don't freeze them in silos. Put them on a national railway system and let them blend in with regular freight traffic. The brilliance of the system was its disguise. To satellites, the VZCharke looked like any other cargo train. No glowing symbols, no suspicious shapes, just boxes on wheels. Inside, though, it carried its true cargo, 3 RT, 23 Molodets ICBMs, NATO reporting name STS, 24 Scalpel, each armed with 10 nuclear warheads and boasting a range of over 10,000 kilometers, launched vertically straight out of the railcar as the roof popped open. But the train wasn't just a launcher. It was a fully self-contained rolling military base, complete with independent power, secure communications, sleeping quarters, missile maintenance systems, and armed security detachments. It could run endlessly across the world's largest railway network, switching lines, disappearing into freight yards, and giving American intelligence analysts endless headaches. A nuclear train might sound absurd, but strategically it was brilliant. Mobility meant survival. It couldn't be pinned down, changing routes, patterns, and stopping points daily. Satellites struggled to spot it because it looked perfectly normal. And in wartime, it could launch from almost anywhere, needing only a standard stretch of track to stop, open its roof and fire. In a world where immobile missile silos were sitting ducks, the Molodets was a shape-shifting ghost. Of course, nothing screams Soviet engineering like a brilliant idea weighed down by very real problems. The missile cars were absurdly heavy, damaging civilian rail lines not built for that kind of punishment. Constant mobility was a logistical nightmare. Keeping nuclear missiles operational while bouncing around the countryside? Not easy. Safety was also a concern. Nuclear weapons and endless train motion are not the most comforting combination. Arms control treaties further complicated everything. You can't exactly show inspectors your disguised doomsday train without giving away the whole point. After the USSR collapsed, the system grew too expensive to sustain. The last Molodets trains were retired by the early 2000s. Russia flirted with reviving the idea as the VZCharke bargain, but funding cuts and shifting priorities killed the program in 2017. But for true Soviet audacity, Nothing beats the moment the USSR decided a tank should have wings. The Lewin-class Ekranoplan, the Caspian Sea monster. Imagine skimming across the ocean at jetliner speeds, not in a plane, but in something that looks like a battleship welded to a pair of wings. That's the promise and the absurd charm of the Lewin-class Ekranoplan, the Soviet Union's legendary Caspian Sea monster. It wasn't quite a ship. It wasn't quite an aircraft. Instead, it lived in the strange twilight zone of engineering known as ground effect, where physics takes a look at normal flight rules and says, let's do something weird. Think of an Ekranoplan as a flying hovercraft's overachieving cousin. It's a surface effect vehicle designed to glide just a few meters above the water, riding on a cushion of trapped air. This low-altitude sweet spot reduces drag, boosts efficiency, and lets the craft rocket forward faster than almost anything else that touches water. The Lewin didn't soar. It skimmed like a skipping stone. The Lewin was the crown jewel of Soviet Ekranoplan engineering, designed in the late Cold War years by Rostislav Alexiev's bureau. 74 meters long, about the length of a football field, with a 44-meter wingspan and an empty weight of 240,000 kilograms. Yes, empty. 8 in K. 87 turbofans jutted from its nose like a wall of jet engines strapped to a cartoon villain's blimp. Those 8 engines blasted air beneath the wings to generate lift, then shoved the entire monster forward at terrifying speed. On radar, the Lewin barely showed up, flying too low to track like a plane, too fast to identify like a ship. For military planners, that combo was intoxicating. The Lewin wasn't designed to ferry passengers or deliver mail. Its purpose was much harsher, to carry anti-ship weapons across the Caspian Sea at breakneck speed. 6 hulking Moskit missiles sat on its back like dorsal fins on some mechanical sea creature. The idea? If NATO fleets ever ventured too close, the Lewin would scream across the water at 500 kilometers per hour, unleash its missiles and disappear before anyone fully realized what had just happened. On paper, it was brilliant. In practice, things got complicated. The weaknesses came in like a cold wave. It was enormous, expensive, and painfully difficult to maintain. It couldn't handle rough seas, a surprising flaw for a naval vehicle. And well, the collapse of the USSR didn't help its funding prospects. Only one Lewin was ever built. It served for a few years before being quietly retired, left to sit on a beach near Durban, Russia, where it still rests today. An accidental open-air museum piece and a magnet for aviation nerds. The Lewin-class Ekranoplan looked like it leaped straight out of Cold War comic book. Colossal, futuristic, and ultimately doomed by the very boldness that made it fascinating. Yet the Soviets didn't stop at flying ships. They even turned one of the world's deadliest weapons into something that looked as ordinary as a cargo train. Object 760, the Soviet hover tank that tried to glide into the future. If there's one thing the Soviet Union loved, it was a vehicle that could go anywhere. Through mud, over snow, across frozen tundra, and ideally straight through the kind of swamp that would swallow a normal tank hole. After all, when half your country is either permafrost or marshland, mobility isn't just useful, it's survival. So in the 1960s, Soviet engineers asked a question nobody else dared. What if a tank didn't roll? What if it hovered? This is how Object 760, the USSR's first hovercraft tank, was born. Siberia, the Arctic wetlands that stretch for hundreds of kilometers. To most nations, these were places to avoid. To the Soviet military, these were places they expected to fight. Conventional tanks sank, bogged down, or froze in place. So designers started dreaming about air-cushioned vehicles, hovercraft technology that could glide over terrain like a stone skipping across a lake. If the ideas sound wild, well, it was. But the Soviets never shied away from weird. Object 760 weighed just 5 tons, about the size of a small modern APC. It didn't have tracks. Instead, it had a rubberized air skirt and powerful turbines that blasted air downward, lifting the whole machine onto a cushion of compressed air. Some of its quirks made it sound almost magical on paper. Only 1.7 meters tall, you could practically lose it in a wheat field. 7 meters long, 3.4 meters wide, and astonishingly light. Initially armed with a 7.62mm machine gun, with a planned upgrade to the 73mm Grom cannon. The same gun, the BMP, one used, capable of 80 kilometers per hour on land and 50 on water. For reconnaissance or hit-and-run raids in swamp country, it seemed perfect. The reality is another story, though. Testing revealed Object 760 as both a hovering triumph and a disaster. It could skim over snow like a sled, float on water like a boat, and cross marshes without sinking a centimeter. But firing while hovering was another story. Hovercrafts vibrate constantly and violently, and Object 760 shook like a washing machine full of bricks. Accuracy was laughable, armor non-existent. Small arms fire could tear through the air skirt and disable the entire vehicle. And the engines were so loud they could be heard from kilometers away, completely undermining its light reconnaissance purpose. Ultimately, Object 760 failed because it couldn't overcome its fatal flaws. Too noisy to be tactical, too fragile to survive combat, too unstable to fire effectively, and too complicated to maintain in field conditions. The project stalled, and the hover tank was quietly retired to the military's folder of interesting but insane ideas. Object 760 proved something important. Sometimes the boldest idea is bold for a reason. It doesn't actually work. Still, it's hard not to admire the USSR for attempting to merge a hovercraft with a cannon and calling it a fighting vehicle. Still, this wasn't the USSR's most ambitious vehicle to skim the earth. Bartini Skyboat, the VVA-14, the Soviet aircraft that tried to do everything. Some engineers dream within the borders of practicality. And then there was Roberto Bartini, an Italian genius turned Soviet visionary who looked at the Cold War's anti-submarine problem and decided to just build a flying boat-plane hovercraft VTOL hybrid. The Bartini Beria VA-14 remains one of the strangest aircraft ever attempted, a machine that tried to be amphibious, vertical lifting, long range, and capable of skimming a few meters above the ocean at blistering speed. It was the aviation equivalent of ordering one vehicle that could be your car, your boat, your helicopter, and your summer jet ski. Roberto Oreste Bartini had already built a reputation inside the USSR as a brilliant engineer who refused to accept the limits of conventional aerodynamics. To him, impossible was just a scheduling inconvenience. His dream for the VVA-14 was simple in concept, but outrageous in practice. An aircraft that could take off vertically, cruise like a high-speed airplane, skim over oceans like an equinoplan, and land on water, any water. All of this to hunt American ballistic missile submarines that lurked beneath the waves. In an era obsessed with stopping nuclear Armageddon, Bartini was aiming to create the ultimate submarine hunter. The VVA-14 was a bizarre beauty. 26 meters long with a 30-meter wingspan and a takeoff weight that could pass 50 tons. Powered by turbofan engines for flight and a planned dozen vertical lift engines meant to hoist it straight off the sea. The 12 lift engines never arrived, leaving the aircraft with the body of a VTOL machine, but none of the vertical takeoff magic. Imagine buying a drone and the company forgetting to ship the propellers. Still, the VVA-14 could perform as a normal aircraft and as a low-flying ground effect machine, riding on a cushion of compressed air above the ocean surface. In theory, it was perfect for spotting submarines. In practice, it struggled just to get its pontoons working. The first prototype flew in 1972, conventionally from a runway, because the missing lift jets made vertical takeoff impossible. Due to secrecy, the whole thing was painted like an Aeroflot airliner, as if anyone seeing it would believe a giant sci-fi sea skimmer was just another passenger plane. Inflatable pontoons were added in 1974, so the craft could operate from water, but they behaved unpredictably. Tests showed they could inflate. 2-1-1-9, the bomber that tried to fly on a miniature sun. By the late 1950s, the Cold War had become a competition not just of ideology, but of sheer audacity. The Americans had already strapped a nuclear reactor inside 8B-36 bomber. If the United States could fly with a reactor humming in the belly of a bomber, the USSR wasn't about to be left behind. Thus began the journey of the 2-1-1-9, a project that asked a simple question. What if a bomber never had to land ever? In theory, nuclear-powered aviation was the ultimate strategic flex. A nuclear bomber could stay airborne for days, circling like a vulture with atomic weapons aboard, untouchable by fuel shortages and unpredictable attack windows. The Americans started their nuclear aviation journey with the NB-3060H Crusader, a flying test lab that carried a reactor but didn't use it for propulsion. The Soviets saw this and thought, fine, we'll build one that does. The Tu-1-1-9 was built on the reliable 295 airframe, those iconic swept wings and thunderous 4 turboprops. Except in this version, 2 of those engines weren't fed by kerosene at all. Instead, they were meant to sip heat from a nuclear reactor mounted in the rear fuselage. Of course, this required shielding, a lot of shielding. The cockpit was wrapped in very thick protective layers. Even then, engineers weren't entirely sure the crew wouldn't slowly glow in the dark. To test feasibility, the Soviets created the Tu-95 LAL, a research platform that actually flew with a functioning reactor on board. It didn't power the aircraft, but it proved that, at least in principle, nuclear flight was possible. Nuclear flight that wasn't safe, exactly, but possible. If everything worked perfectly, the Tu-1-1-9 would have provided practically unlimited range. The plane could stay airborne for days or weeks at a time, but every advantage came with a flashing neon asterisk the size of Siberia. Even in the test phase, the minor problems of strapping a nuclear reactor to a vibrating bomber quickly became major. Radiation leaks, because full shielding would have made the plane weigh almost as much as a small moon. Crash risk, since a reactor-powered bomber going down wouldn't just be a tragedy, it would be an ecological disaster, scattering instant fallout courtesy of gravity and maintenance nightmares, where every inspection risked contamination and every malfunction became a full-blown nuclear emergency. It didn't take long for Soviet leadership to realize that one poorly timed bird strike could irradiate half the countryside. By the mid-1960s, technology had moved on. Intercontinental ballistic missiles offered the same strategic reach without sending a flying reactor to patrol the skies like a radioactive vulture. The Tu-1-1-9 was quietly buried, never achieving full nuclear propulsion. The flying atomic laboratory was scrapped, but the next Soviet invention didn't just fly. It skimmed the oceans, rose like a dragon, and hunted submarines like a mechanical sea monster. A-40, the winged tank. World War II was an era of wild experimentation. Among these fever dream inventions sits the Antonov A-40, better known as the flying tank. Yes, someone genuinely looked at a T-60 light tank and thought, what if it soared? Airborne operations were rapidly becoming the new frontier of warfare. Paratroopers were the shock troops of surprise. And gliders, silent, stealthy, and deadly, had already been used with alarming effectiveness by the Germans. The Soviets watched closely. If gliders could deliver infantry, why not something heavier? Something with armor, something that could hit the ground firing. Enter the idea of an armored vehicle descending from the sky like a very angry metal angel. The concept was simple on paper and utterly absurd in practice. Testing promised spectacle, if not outright disaster. The A-40 takes flight, sort of. In 1942, the moment of truth arrived. A TB-3 bomber hooked itself to the winged tank, throttled up, and began the long, groaning process of dragging multiple tons of armored optimism into the sky. It worked kind of. The A-40 lifted off, but the TB-3 was struggling so hard that it was practically begging gravity for mercy. The tow pilot, realizing that he didn't want to be remembered as the man who died towing a tank, released the A-40 early. Miraculously, the tank glided smoothly even. The pilot inside managed a safe landing, shed the wings, started the tank's engine, and that was the end of its one and only flight. The A-40 had 3 fatal flaws. The tank was simply too heavy. No surprise there. Tanks aren't known for being lightweight and aerodynamic. The available tow planes weren't strong enough. The TB-3 wheezed like an asthmatic horse pulling a brick house uphill. Combat practicality was questionable at best. A giant winged tank descending from the sky? Cool visual, terrible operational plan. And so, despite its successful landing, the dream died quietly in a field somewhere, leaving behind one of the strangest footnotes in military aviation history. The Antonov A-40 wasn't a failure of imagination. If anything, it proved the Soviets had imagination to spare. It was bold, creative, and utterly impractical. A glorious what-if that never had a chance against the physics of its own ambition. But while the flying tank remained fantasy, the Soviets soon pursued something far more dangerous. A bomber powered not by fuel, but by a nuclear reactor. Thank you for joining us. Feel free to click on one of the cards on the screen to watch another video. Don't forget to like and subscribe to the channel. See you in the next video.